Hello students, welcome to the channel of Parallax Tutorial. My name is Pallabi and this is our fifth video on the series of topic-wise past paper questions of IBAAHL Mathematics Paper 1. We are covering the topic of functions. You can access my previous videos by clicking on the link given in the description. We'll be doing the first three subparts of the given question on functions in this video. The concept of partial fractions, differentiation using the power rule, and how to calculate the range of a given function without using the calculator is explained in detail here. Please pause the video and take down notes if required. We'll be covering the first three parts of this question. So let's begin. The function f is defined by f of x given as 2x minus 1 divided by x plus 2. And the domain is also given. Domain is minus 1 less than equal to x less than equal to 8. We have to express this function in the form which is given over here. Now, this is very important because when we do calculus, you all will see how important this partial fraction becomes. So therefore, 2x minus 1 by x plus 2 has to be written in this form, right? So here's what we do. Look at a plus b by x plus 2. Let's take the common denominator, x plus 2. And what do we get in the numerator over here? Ax plus 2a plus b. And on the other side, we have 2x minus 1 divided by x plus 2. Now, all we need to do is compare the coefficients of the numerator since the denominators are already same. So we can just compare the coefficients of the numerator, which means if you look, the coefficient of x, coefficient means the term which is preceding the variable. So x's coefficient is a, therefore a is equal to 2. And 2a plus b is equal to minus 1. Let's plug in the value of a over here. So we get 2 into 2 plus b is equal to minus 1. 4 plus b is minus 1. B is equal to minus 5. Therefore, the answer for this part would be a is equal to 2, b is equal to minus 5. Hope you got this. Let's move on to the part B. We have to now show that f dash of x has to be greater than 0 on the same domain which is given over here. So, which means we have to differentiate the function f of x. Let's do that. Remember, before differentiating in this particular part, let's first write down the function. F of x is 2x minus 1. So we're doing part B, and this is x plus 2. We have to differentiate this, right? We can write it in two separate parts and then differentiate it, or we can use our first part's result because this is the second part to the same question. So let's use, in fact, the result of the previous part, which means 2x minus 1 by x plus 2 could be written as a plus b by x plus 2, right? Our a value was 2, which means it's 2 plus b is minus 5. So it's minus 5 by x plus 2. The reason we are doing this is now this question becomes a little simpler to differentiate. Otherwise, when we have this, we might have to use quotient rule or some substitution, but that would complicate things and it's just a 2 marker, right? So, which means we use the previous part to do part B. Now, clearly, this function can be written as 2 plus minus 5 by x plus 2. Which means now all we have to do is we have to differentiate this. So let's differentiate it. F dash of x would be differentiation of any constant, which is 2 in this case would be just 0. And we have a minus 5 by x plus 2, right? So if you remember the power rule of differentiation, it can be written like this. I'm just breaking this down so that you understand it better. So actually, let me write it like this. F of x can be expressed further as 2 minus 5 x plus 2 to the power minus 1. Clearly, we know that the differentiation of 2 would be 0, but it is minus 5 times x plus 2 to the power minus 1. We'll use a power rule. Power rule states what? If you have y as x to the power n, let's say, or ax to the power n, where a is a constant, then if you differentiate y, n comes on this side, n a x to the power n minus 1. This is the power rule for differentiation. Let's use that. Therefore, when we differentiate f dash of x, it becomes 0 minus 1 comes down. There's a 5 and there's x plus 2, minus 1, right? So it's 0 plus 5, x plus 2, minus 2 to the power minus 2. Or let me erase this side now. F dash of x, that means, can be written as f dash of x is equal to 5 by x plus 2 whole square. This is what we have got. Now the question says that we have to show that this is greater than 0. Clearly, we have a positive number on the top, which is numerator is positive. And look at the denominator. So it depends on the value of x, right? So if we take x as a positive number, we'll get f dash x greater than 0. Even if we take x as a negative number, then also, since the new denominator is squared, we'll get f dash x greater than 0. Hope you understood this. So therefore, we can say that f dash x for the given domain will be greater than 0. Now, coming to the last part, which is we have to find the range of function f. Now, in my previous videos on this same series, I have explained the concept of range as well as domain. You can check back and look at the videos just to see how domain and range work. However, very quickly, I'm going to again reiterate how or what range of a function means. So the function over here is given as 2x minus 1, x plus 2. This is our function. And the domain, which means all the values which x can take or it can be inputted in the function, is from minus 1 all the way till 8. These are the values which can be input into the function. The function is this. Let's input minus 1 and let's see what we get. So when we put minus 1 into the function, we get 2 into minus 1 by minus 1 plus 2, which gives us what? Minus 2 minus 1, which is minus 3. That's one part. And if we input 8 into the function, let's input 8. So I'm going to erase the left-hand side now, since we have already covered the B part. So we're going to input minus 8, which is the other end of the domain, just to see what we get the function as. So when we put 8 into the function, f of 8, we get 2 into 8 minus 1 divided by 8 plus 2. Which is 16 minus 1 by 10. 15 by 10 or 3 by 2 when you divide by 5. Now you could have also used this form because after all we can use part A also, but if you use this there will be no deduction in the marks, right? So we can use either form to find out the range. Therefore, what did we get? We saw that if we put minus 1 as the domain, that is the lowest possible value, we get minus 3. And if we put 8 as the domain, that is as the input value, which is the highest possible value of the domain, we get 3/2 as our function f of x. The function values are written on this side, right? So this is where we get our function values. All the values, or the function values, or the y values as we call them, all the possible values constitute the range of the function, which means -3 to 3/2 would be, including both the values, would be the range of the function. Please note that there are two kinds of brackets which are used. So if you use a broad bracket, it means that we are also including the term -3 as well as 3/2 in the range of the function. On the other hand, if you use a simple bracket like this, it would mean that -3 and 3/2 are not included, and anything which is, basically it means like this: -3 is less than f of x is less than 3/2. However, this is not the case because we have found that -3 and 3/2 are both included in the range of the function, and that's what the range of the function is. For the next part, which is part D, please watch my next video. The link will be in the description below. Thank you.